In Algebra 2, section 2.5, we're dealing with scatter plots. So basically what this is we're going to find a line that helps predict essentially real life. Scatter plots are more of a real life representation because when we do data like census or when we're trying to predict how long someone will live, things like that, it's not always an exact science. You don't always get an exact number. In fact, you get variations. And what the line of fit does is it helps us figure out all of these information and see if there's a positive correlation, a negative one, or there's no correlation. That means, is there a pattern, basically? And if there is a pattern, how can we use that pattern in order to predict what might happen in years to come? So when we have, these dots essentially are data information, so graphing, so they're scatter plots. And so just like you did in middle school, you're going to graph the scatter plot, but this time you're going to try to find what is called a line of fit. And so these are these red lines right here. And a line of fit, basically, it's a line that connects at least two or more dots together and kind of evens out the rest of the dots on top and bottom. So that means I don't put a line up here so all the dots are on the bottom. I put it somewhere in the middle so there's an equal amount of dots on both sides and it goes through at least 2 points. So this one here, it goes at least 2 points. This one went through 4, and there's dots on top and dots on bottom. Again, it doesn't have to be exact, but again, because it's not exact, you're going to have different answers. But for the most part, you should be able to predict kind of around the same area. So that means if you're comparing answers with your neighbors, you can have different equations, different answers even, essentially, but they can't be way off. And then we have something called no correlation, which means that they don't have any relation, really. You can't do positive or negative, it's just all over the place, so then we can't find a pattern. So here is actually what's going to go on your flipper. There's no key concept box that we're going to have, but this goes on your flipper. So the first thing we're going to do is we're going to plot the points. So that's plotting the points. Once I plot the point, then I'm going to draw this red line of fit. When I draw the line of fit, I'm going to, again, balance it. That's a term, balance. So that means I want to go at least how many? Two or more lines. 2 or more points. I'm going to take this and go 2 or more points and then kind of even out. Put it in an area where there's dots on the bottom and on top, an equal amount. And then the third thing I'm going to do is I'm going to pick 2 points from that line. So sometimes you'll have only 2 points, sometimes you'll have more than 2 points, you'll have choices, but I need only 2 points. Once I find those 2 points, then I'm going to go back to the beginning of chapter 2 and use those 2 points and the point slope form to find an equation. This equation we find is called the prediction equation. So go ahead and write this down. Don't forget the vocabulary. Just pause it and write it down. We're going to move on to an example. So make sure you write this down clearly so that you can have it in your flipper. So here is our first and only example, actually, and it's going to ask for this information is giving us the percent of college students applying for 2 or more colleges. Sometimes on this one they're going to give you the actual year. But it's easier if they give us a year since. So that means they started calculating this information since 1985, and this will tell you how many years. So if I wanted to know what year this represents, I'm going to add 12 to 1985. Sometimes they'll give it to you in years, sometimes they'll give it to you this, but either way, it doesn't matter which way you decide to represent it. It's just dealing with 1,985 as a number instead of 12 there's a big difference in your math. But you don't necessarily have to put it down. And if you're confused on that, don't worry, we're going to explain that in class when you do the practice problems in class. So the first thing is going to tell us to graph this information. So the thing that's dependent is a percentage. So always that goes on the x, this is the definite. Okay, this is the thing that doesn't change no matter what. So no matter what the percent is, the years will never change. But according to the years, the percent. So this is my x, and this is my y, because my x never changes. So this is, usually it's time. So this is going to be years since 1985. Okay? We're going to do 0, 3, 6, 9, 12, 15. And this one is going to be percent. And the percent will go by, let's see, sorry, I'm fixing this. The percent will go by 5. So 5, 10, 15, 20, 25. So let's graph. The first one, so our first step again in our thing is to plot the points. We're going to plot the points. 0 goes all the way up to 20. Okay? 3 is going to go up to 18, so just a little lower. This doesn't have to be exact, but it has to be, you know, be as precise as you can. 6 is 15, so around here. 9 is also 15, so we have to make it equal. 12, it's not quite equal, is 14, so a little lower than 15. And 15 is 13. Okay, so as you can see here, this is sort of a negative correlation. It's really tight. It's a negative correlation in the sense that it's as the years go on, there's less and less kids applying to 2 or more colleges, which makes sense. So here we're going to draw a line, and I need to have, well, I don't have a ruler, so I'm just going to draw it here. So what I want to do is I want to draw a line through 2 or more points, but then I kind of want to even out how much is on top and how much is on bottom. Okay, so it's not an exact line necessarily. Let me see if I can draw that a little bit better because I don't have a ruler with me. So the 3 lines I chose is these 3 right here. 1, 2, 3. Okay, so it was 3 lines. There's 1 point on top and there's 2 points on bottom, which is okay. It's not exact. But at the same time, I didn't draw it all here, so that all the points are on the bottom. So I try to balance it out as much as possible. It's not going to be the best. Our next step, in order to find the equation on the one that you drew for your flipper, we got to choose 2 points on this equation, any 2 points. So it seems like the best 2 points is this one and this one. And let's find those 2 points. This is 9, 15. This is 15, 13. Now some of you guys might have ended up with different lines, and that's okay, and you will in your example problems. Different points. But once we identify those points, then it's this whole point is just to do exactly what we did in the first part of chapter 2. So I'm going to use this and I'm going to find the slope. So here's my x1, y1. Here's my x2, y2. Let me make sure I have my calculator. Okay, so first is to find the slope. And the slope is the equation y2 minus y1 over x2 minus x1. So y2 is 13 minus 15 all over 15 minus 9. So 15 minus 13 is 2. 15 minus 9 is 4, making ours 1/2. Okay? Once we find it, we're going to plug it into our equation. What is it again? Y equals mx plus b. We know what m is, and we're going to choose any of these points. Let's choose this one first. So my m and x and y, we need to plug that all in so that we can solve for what letter here? B. Hopefully you remember this from the first part of chapter 2. So y is 15. My m is 1/2. My x is 9 plus b. Okay? So this is 15 equals 1/2 of 9 is 4.5 plus b, right? And 15, and then we subtract 4.5 from both sides. We end up with 10.5 equals b. Okay? So our equation here sorry, this is not a good color, you guys don't forget. Our equation here, this is our b, and this is our m. So it's y equals m, which is 1/2 x plus 10.5. And that's our equation. So that's b. Y equals 1/2 x plus 10.5. Now the last part, we're going to be using this equation. So that's where it's very important that you have somewhat similar equation than than other people. So even though it's different problem answers, it should be similar or at least close. So we want to predict the percent in 2010. The problem is these numbers are not in years. They're actually years from 1985. So how do I find what 2010 is? Well, the simple thing to do is to take 2010 and subtract it from 1985 so that we know how many years. So we're going to take 2010 and we're going to subtract 1985. This gives us 25. So this is 25 years. And when we're talking about years, am I talking about the x or the y? Because it's years, I'm talking about the x. So essentially, I'm going to take this, I'm going to plug it in for x, and then I'm going to find how much percent it's going to be in 2000, or would have been. This book, I think, was created before 2010. But would have been in 2010. So here we go. Our equation again is y equals 1/2 x plus 10.5. I'm going to plug in 25. So y equals 1/2 of 25 plus 10.5. This gives me 1/2 of 25 is 12.5. So y equals 12.5 plus 10.5. And then y, 12.5 times 10.5, I'm sorry, 12.5 plus 10.5 is 23. So what this tells me is that in the year 2010, 25 years from 1985, 23% of students will apply to 2 or more colleges. So of course this is pretty long, and including the one what you have on your flipper information down here, plus all this is a lot of information. But it's just simple to take step by step. This part is something you learn in the first part of chapter 2. So go ahead and try one on your own, page 88, number 2. Page 88, number 2. We're only going to do one because it's pretty lengthy, but once you get the hang of it, you'll be doing fine. So bring that in tomorrow, and I'll see you guys then.